Okay, so while the conversation about the weirdest things we have eaten continues in the chat, we are going to be learning about number bases today. So yeah, and I guess we're getting right into it.
Okay, so this is the base 10 number system. So as you can see on the bottom, it shows 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, and so on. So these are kind of the places for numbers. So for example, think about the ones place, the tens place, the hundreds place, the thousands place, and so on. So basically, each number represents a power of 10, a multiple of a power of 10. Next slide.
Hopefully you guys learned this in kindergarten, hopefully. But we
Yeah.
are just going over this anyway.
Yeah. Okay. So for example, the number 3055 would be 3 times 10 to the power of 3 plus 5 times 10 to the power of 1 plus 5 times 10 to the power of 0. So basically, again, as I said, it's a multiple of a power of 10. So 3 times 10 to the third, 5 times 10 to the first, and 5 times 10 to the 0. And remember that the fives represent different values. So the orange 5 is like 10 to the power of 1 times 5. So it's a greater multiple than 5 times 10 to the power of 0, which is the red 5. Next slide. So basically, as you can see by the red numbers, each place value is a consecutive like power of 10. So it's 10 to the power of 0 as the rightmost place value, then 10 to the power of 1 as the second rightmost place value, and 10 to the power of 2, 10 to the power of 3, and so on as we're going leftward. So the power of 10 increases as we go to the left. Okay, and next slide. Okay, so one more thing, what digits do we use in base 10? So we use 0 through 9, right? So if you want to represent a number like 10 in base 10, you'd have to use 2 digits because there's no like value for 10. There's no like, I don't know, letter that we can use to represent 10. We'd have to use multiple digits because we only use 0 through 9 as our digits. So yeah. Okay. So oh yeah, sorry.
So this is the binary number system. So instead of using 10 as a base, this one uses 2 as a base, and it follows the same pattern where the first one is 2 to the 0th power, and then the next one is 2 to the first power, and then 2 to the second power. And so for base 10, what digits would you use? I mean, for base 2, what digits would you use? Yeah, you would use 0 and 1 because if you put a 2, then it would be overflow and could go to the next digit over. So what is binary numbers used for, and why is it useful? Yeah, it's mostly used in code and computers because computers only use the numbers 0 and 1 to represent everything. But it's used because you could count on like you count higher numbers with like less digits. So what's the highest number that you count on your hand? Yeah, on your hand, with one hand, you can only count to 5. But with binary numbers, you can count to 31. And so this is how you use the binary system. So as you can see, there's a 1 in the 2's place, meaning that there is 1 2's. So this number is 2.
Okay, so now that you know like how to convert into binary, here's some practice problems. So if you can, try to convert 11 base 2 into decimal form, which is basically base 10. Okay, yeah, so I'm seeing a lot of correct answers. The correct answer is 3, because if you put 11 into the little chart at the bottom, you got 1 into the ones place, which is 1 times 2 to the 0, which you get 1, and then 1 times 2 to the first power, which is 2. So then you add them together, and that will give you 3. Okay, the next problem. Okay, so for the next problem, you're going to try to convert 4 base 10 into binary. Yeah, so you guys seem to be catching on pretty quickly. So the correct answer is 100. Basically, you just need a 1 into the 4's place, and that'll give you 4. Okay, try to convert the number 1010 and base 2 into decimal. So yeah, just like the other problem, you'll put 1010 into the bottom, and that'll give you 1 times 2 to the third power plus 1 times 2 to the first power. So that'll give you 8 plus 2. Okay, so if you look at the bottom and how it says 1's place, 2's place, 4's place, and 8's place, basically those represent like different powers of 2, because you can only use 0 or 1. So if you see a 0 in that value, for example, in 1010, you'll see that there's a 1 in the 8's place, which means that there is a basically you have to multiply 1 times 2 to the third. But if there's a 0, that kind of just means that there's like no value there in a sense, because like, for example, if I have like 1010 in base 10, it's just going to be a 0 in like the base 1 spot, right? So kind of think of it as like the same thing. So basically there's just no value, but whenever there's a 1, there is the value. So you have to multiply the 1 by like the exponent value, so it'll be 2 to the first.
Does that make sense? So wherever there is a 1, that means there is a value there. So if there's a value in the 8th place, then that means this number has an 8 in it. And if there's a 1 in the 2's place, that means this number has a 2 in it. And so at the very end, you sum all those together. So it has an 8 in it and it has a 2 in it. Then you do 8 plus 2, which equals 10. So that's how you would convert it to decimal. Yeah. And if it has a 0 in it, and it just means it doesn't have any of that number in it. So you don't need to worry about it.
Okay, for the last problem, you're going to try to convert the decimal number 13 is 10 to binary. Yeah, so the answer is 1101. If you add up the 8 plus 4 plus 1, you get 13.
Okay, so I think Ruth mentioned that using base 10, you can count to 5 on a hand, right? You can count 1, 2, 3, 4, 5, and that's it for one hand. But if you use binary, you can actually count to 31 on one hand. And the way we're going to do that is not because you have 11 fingers or because you get more fingers. You're still using 5 fingers. It's just that this time we're going to pretend each of the fingers represents one of the binary place values. So my thumb is going to represent the place value of 2 to the 0. So actually, let me draw a little picture because I think that will help you guys visualize it. So here's my hand. Okay, and this one is my thumb, right? I'm just going to label that thumb. Okay, so my thumb is going to represent the place value of 2 to the 0. So that's just the ones place. And my pointer finger is going to represent the place value of 2 to the first power. So the 2's place. My middle finger is going to represent the place value of 2 to the second power. So 4 and all the way. And my pinky is going to represent the place value of the 16th place. Okay, so this is base 2. And how you would count to 32 is that you just run through the numbers one by one. So, oh, I will put spotlight. Okay, there, now you can probably see me. So to do this first, we're gonna just count. So first we'll start off with 1. So this is 1 in base 2 because 1 in base 2 is just 1. The thumb is the 1. And then 2 in base 2 is my pointer finger, right? And so then how would you guys make 3 with using your thumbs in base 2 or using your fingers? If you could, you should turn on your cameras. Yeah, 3 would be this L sign. And we're gonna skip 4 because it's a funny number. And okay, 5 is okay. 5 is okay. How would you make 5? I can't really bend my fingers that well. 5 would be like this, but it's not working. So 5 would be like your middle finger and your thumb, and I'm just gonna hold it like this because my finger won't stay up. Stupid finger. Yes, middle finger and thumb. Okay, how would you make 6? Yeah, middle finger and pointer. So this is easy to make. And how would you make 7? Yeah, we would use all 3 of these fingers. So the first 3 fingers. And now I'm gonna jump to a different number. How would you make 10? Yeah, it would be these 2 fingers. My hand does not work. My fingers keep going down. Okay, yes. How would you make, let's do 13. How would you make 13? So 13 would be like, you would need 4 and 8 to make the 12 part, and then the 1 part to add 1 more. So this would be 13. So now we're gonna sort of reverse it. So now I'm gonna show a random number and you're gonna have to figure out what it is. So let's do this one. What number is this? yeah, this is 24 because this is a 16 finger and this is the 8 finger. So 8 plus 16 would be 24. And okay, let me do another one. Let's do okay, what's this? Yes, this would be 14 because it's 2. This is the 2 finger. This is the 4 finger, and this is the 8 finger. So that would 2 plus 4 plus 8 would be 14. Let's do this one. This isn't working. My thumb, my weird finger that can't stand up straight, and my pinky. Yes, that would be 25 because this is the 1 finger plus the 8 finger plus the 16 finger. So that'd be 25. How about a full hand? What would that be? Yes, a full hand would be 31 because that would just be 1 plus 2 plus 4 plus 8 plus 16. So it looks like you guys have got the hang of it. Now, okay, I'm gonna ask a couple of other questions. So how would you, okay, you guys should hold up your hands once, hold up the number once you have it. So how would you make the number 30 on your hand? And I'm not gonna hold my hand up. The number 30. Yeah. So for 30, you would hold up those last 4 fingers. So good job. How would you make the number 29? Yep, you guys got it. I think you guys have a pretty good understanding of binary. And now you can go around to all your base 10 friends and be like, I can count to 31 on one hand. So good job, everyone. Yeah, base 10 friends. And then, yes, okay. So that was, you guys did a good job with that. So yay.
I got a question.
Yes.
Could you count every single finger on a binary hand?
Wait, could you say it again?
Could you count every single number on the binary hand till 31?
Yes, you can. I can actually walk through all the numbers. I'll do that real quick. So okay, well, the hand's gone, but you guys know what it means. So 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So that's how you count to 31 using only one hand. Yes, number 4 is always funny. It's just one of the perks of having a middle finger. But yes, now you guys know how to count to 31. Okay.
Okay, so now that we know how to convert binary to decimal, we're going to do decimal to binary. So just base 10 to base 2. So first what we do is so first find the largest binary place value smaller than your decimal value. So for example, I'll just take like 50, not 53, sorry, I'll take like 67. Okay. If my Okay. Ooh. Wait. Let me just erase the hand here. Okay. So 67, right? Say that's our number. Okay, it's not erasing the hand on my part. So like it's just gonna lift it, right? So what's the greatest power of 2 that's smaller than 67? Power of 2. So 6 would not be a power of 2, but 2 to the power of 6 would be. Just say what the number is. Okay, so 64, yes, is the answer. So 64 is less than 67, and 64 is 2 to the power of 6, right? So we'd have 1 for 2 to the power of 6. Now we subtract 64 from 67, and we are left with 3, right? So how many multiples of 2 to the power of 5 fit in it? So does 32 fit into 3? Just say yes or no. Right. So that would mean that there would be a 0 in the 2 to the 5's place. Now 2 to the 4, right? That's 16. So how many 16s fit into 3? Right. So 0. Then 2 to the 3rd. So that's 8. How many 8s fit into 3? Right. 0 again. And then 2 to the power of 2. So how many 4s fit into 3? Right. And then 2 to the power of 1. How many of those fit into 3? Right. So we'd have 2 to the power of 1. And don't forget, we also have 2 to the power of 0. So after we subtract 2 to the power of 1, which is 2, from 3, we are left with 1. So how many 2 to the power of 0s fit into 1? Yes, 1. So our number, if we were converting 67 from decimal to binary, would be 1 0 0 0 0 1 1. So I saw a lot of people who were able to convert that like really quickly, but a lot of you probably were unable to do that at first. So hopefully it's something you're able to learn. So let's just try one more example, so you all are able to get this. So let's try 102 in binary. So okay, so what's the greatest power of 2 that fits into 102? Yes, so it would be 64, which is 10 to the power of, or not 10, sorry, which is 2 to the power of 6, right? So 164 would fit into that, right? 1 times 64 would fit into that. So what's 102 minus 64? Yes, it's 38. So now we have 38 from 102. So how many 2 to the power of 5s, which is 32, fit into 38? I don't know why all of you are saying 3. Like, I genuinely don't.
How many 32s fit into 38, guys?
Yeah.
It's not how many 32s. Why does one person type in 3 and then everyone follows 3?
I feel like some
Because
of
they
you
don't
are-
want to solve the question themselves, including me.
Nah, I saw everyone putting 3 and I thought it was really funny.
Right. So yeah, it's 1. So good job to the people who got that right before I pointed out that 3 doesn't work. So we have 32. So that can fit into 38. So what's 38 minus 32? Right, it's 6. So how many 2 to the power of 4s fit into 6? Right, 0. So 2 to the power of 4 is 16, and we can't fit 16 into 6, right? So next we get 2 to the power of 3. So 2 to the power of 3 is 8. So how many 2 to the power of 3s fit into 6? Right, 0. Then 2 to the power of 2, how many of those fit into 6? Good job. Yeah, 1. And then 2 to the power of 1. So we have 2 to the power of 2, which is 4. So after we subtract 4 from 6, we get 2. So how many 2 to the power of 1s fit into 2? Yeah, 1. And remember, we also need to include the 2 to the power of 0 always. So how many, after we subtract 2 from 2, we get 0. So how many 2 to the power of 0s fit into 0? Right, 0. So that means that our answer is 1, 1, 0, 1, 1, 0, or sorry, 1, 1, 0, 0, 1, 1, 0, right? Think about it like if we were to have like 10 in binary and decimal versus 1 in decimal, there'd be different numbers. So like remember, you have the 2 to the power of 0. You always have like the rightmost values included in your number, even if they are just 0. So yeah.
Also, one more thing, just to double check our answer, we can add up the place values just to make sure it matches our original answer. So over here we have a 64 plus, oops, 32 plus, and then we don't have any 16s and we don't have any 8s. So it would be plus a 4, which is from here, and then finally plus a 2. And so that should equal 102. Should. Let's see if it does. And yes, this does equal 102, which means that we converted the number correctly.
Mhm. Okay, so good job to everyone. So there was an example 67. I'm pretty sure I used 67, but yeah. Okay, so we're doing 2 questions. So what is 15 in binary? So put your answers in the chat. Okay, so I'm seeing a lot of the same answer. So wait, I can write this out. Yeah. Okay, so let's just number this. Let's number each of the place values. So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So you'll see that I'm numbering from the right. You can number from the left, like the place values. It doesn't really matter. You're gonna get the same place values. But just make sure that your your rightmost value is always 2 to the power of 0. Otherwise, you'll get the wrong number. So, what's the greatest power of 2 that fits into 15? Right, it's 8, because 2 to the power of 4, which is 16, is greater than 15, so it doesn't fit into 15. So we'll have 1 2 to the power of 3 in 15. So after we subtract 8 from 15, we're left with 7. So how many 2 to the power of 2's fit into 7? Good job, it's 1. So 2 to the power of 2 is 4. So when we subtract 4 from 7, we get 3, right? So how many 2 to the power of 1's, which is just 2, fit into 3? Good job, it's 1. So 3 minus 2 is equal to 1. So how many 2 to the power of 0's fit into 1? Okay, yeah, good job. That's 1. So you can see that we get 1, 1, 1, 1 as our answer. So we can just convert it back to decimal just to make sure. So 2 to the power of 3, which is 8, plus 2 to the power of 2, which is 4, plus 2 to the power of 1, which is 2, plus 1 is equal to 15, which is our answer, so, which was given in the problem. So that means we did it correctly. So our answer is 0, 1, 1, 1, 1, or 1, 1, 1, 1. So good job. Then, okay, so next problem. What is 27 in binary? Okay, I am seeing a lot of answers. So good job if you did it. So in binary, so I'm just gonna number the place values again, because remember, like, binary is not your like normal number base, so it's really easy to get mixed up because, like, unlike base 10, you haven't been learning this since you were like an infant, right? You know, so it can't hurt if you number the place values, right? So 27. So what's the greatest power of 2 that fits into it? Into 27. Binary questions, it's more of like if you're given like AB base 2 is equal to AB base 3, what are A and B, right? Those are the
ask
types
weird
of
questions like that.
right. But you will know that like AB base 2 would be equal to A times 2 plus B times 1, and BA base 3 would be equal to B times 3 plus A times 1, and you'd be able to solve like that.
Yeah. In other words, once you learn more number bases, you can set up an equation to set them equal to each other.
Right. So you can solve it algebraically. Okay, so 2 to the power 4, which is 16, is the greatest power of 2 that can fit into 27, because remember the next power of 2 is 32, right? And 32 is greater than 27. So after we subtract 16 from 27, we're left with, okay, that is not a number. We're left with 11. So how many multiples of 2 to the power of 3 fit into 11? Today we will be going a bit over base 3, but I don't think we're really going in depth right now. Just focus on this. And yeah. Okay. So how many 2 to the power of 3s go into 11? Right. Good job. So a 1 to the power of 3, which is just 8, fits into 11. So after we subtract 8 from 11, we're left with 3. So how many to the power of 2s fit into 3? Right, it's 0. So because 2 to the power of 2 is just 4, and 4 is greater than 3. So how many 2 to the power of 1s fit into 3? Good job, it is 1. And remember, 2 to the power of 1 is equal to 2, so 3 minus 2 is equal to 1. So lastly, how many to the power of 0s fit into 1? Right, good job, it's 1. So we now get 1, 1, 0, 1, 1, which is what I'm pretty sure everyone else was putting into the chat earlier. So that should be your answer. And remember, we can check this again. 16 plus 8 plus 3 plus 1. Sorry, plus 2 plus 1, which is equal to 27, is 27. So therefore, we did it correctly.
Okay, so now we're going to do some converting to binary to decimal practice. So if you haven't gotten it by now, basically you find all the place values where the digit is not 0. So for binary numbers, since you can only be 0 and 1, you find all the place values where the digit is 1, and you multiply the place value by the digit, and then you add up all the place values.
Ooh.
Okay, so our first practice, what is the binary number 101010 in decimal? Yeah, so people are getting the right answer. So you first go to the highest place value and with the 1. And so that would be 1 times 2 to the 5th, which is 32. And then you go to the next place value with the 1, and that'll be 1 times 2 to the third, which is 8. And then you go to the next place value with a 1, and it'll be 1 times 2 to the first, which is 2. And then you add them all together and you get 42. So what is the binary number 11101010 in decimal? So we're gonna do the number like the big number and not the one in the question. Okay, so we're getting some different answers. So first you would go to the highest place value with a 1, which is 2 to the 7th. And so it was 1 times 2 to the 7th, which is 128. And then 1 times 2 to the 6th, which is 64. 1 times 2 to the 5th, which is 32. 1 times 2 to the 4th, which is 16. 1 times 2 to the 3rd, which is 8. 1 times 2 to the 2nd, which is 4. And since there's a 0 in 1 times 2 to the 1st, you skip it and do 1 times 2 to the 0th, which is 1. You add it all together and you get 253.
Okay, good job, everyone. Should we do this practice? Or do you think we can just keep going? Okay, I think we can probably just keep going because it looks like you guys have the hang of it. So yeah, we will, unless you guys want to do this practice. Do you guys want to do this?
I don't
No.
want to.
Okay, then
It's
we
gonna
will
take
just
forever.
move on. Okay. Okay, we can do we won't do the charts. We'll just do some other ones. So like this one. Okay. Okay, Ishani's not feeling too well right now, so I will take her slides. So you guys do this problem. Express 43 in base 2.
But what's the difference between base 1 and base 2 again?
Base 1? Base 1 is it's not really
Hey, what's
like
base? Oh,
base 1 is weird. It's not really considered a number base because a number base has to have like at least a 1 and a 0, but base 1 wouldn't be able to have that. So it's not really considered a number base. Yes, every power of 1 is still 1. So really it would just be, yeah, base 1 is kind of weird. I think it's called like unary. Okay, looks like we have some people answering this question. So I will walk through this real quick. So the greatest power of 2 that is less than 43 is 2 to the 5th, or 32. So then we do 43 minus 32, and that gives us 11. And so after that, the greatest power of 2 that fits into 11 is 8. So we would subtract 8 from that, and that gives us 3.
Like 50 of them, which is
And
good.
after that, the greatest power of 2 that fits into 3 is 2 to the first power. So that next we would subtract 2 from that, and we get 1. And so the biggest power of 2 that fits into 1 is 2 to the 0. So there would just be another 1 here. Oops. And so this would be our answer, 1, 0, 1, 0, 1, 1. Good job, guys. Oh, we just did that. We are going to skip it. Okay, whoa. Oops, I may or may not have shown you guys the answer, but we're gonna hope that you didn't see that. Express 241 in base 2. After these few questions, we will introduce base 3. So you have that to look forward to. Okay, looks like most people are getting the correct answer. So for this one, we would look for the biggest power of 2 that fits into this number. So the biggest power of 2 that fits into 241 is 2 to the 7, so 128. And 241 minus 128 is 113. So after that, the biggest power of 2 that fits into 113 is 64, 2 to the 6. So we put a 1 in that place. And then that gives us 49. So the biggest power of 2 that fits into 49 would be 32. And so that gives us 17. After that, I'm going to erase these because they're getting in the way. And then the biggest power of 2 that fits into 17 is 2 to the 4th. So we would have another one there. We subtract 16, that gives us 1. So the biggest power of 2 that fits into 1 is 2 to the 0, which is just 1. So everything else now becomes zeros. So our answer would be 1, 1, 1, 1, 0, 0, 0, 1. So good job. Okay, I think we're gonna do one more, and then we will move on. Okay, one last question, then we're gonna introduce phase 3. Ruth, you can do this.
Okay, so convert 1010110 to base 10. Yeah, so people are getting the right answer. You go with the highest place value, which is 7th place.
Wait.
Oh no.
Oh
sorry.
wait, no, yeah.
Yeah.
D6.
2 to the 6th power, which is 64. And then the next highest is 2 to the 4th power, which is 16. And then next highest, 2 to the 2nd power, which is 4. And then next 2 to the 1st power, which is 2. And you add it all up, and it's 86.
Wait, so is converting binary to base 10 just the same as converting binary to decimal?
Yeah, base 10 is decimal. It's just a synonym.
Okay.
So base 10 equals decimal. Okay, Ruth, you got this too.
Okay,
Oh, wait, sorry,
so
sorry, that's Angela, sorry.
Okay, so now that you know about the base 2 system, the binary system, now we're going to talk about the base 3 number system, which is also known as the ternary system. So so basically, what should the place values be for base 3? Yeah, so I'm seeing a lot of you are getting it correct. Basically, it'll just be 27, 9, 3, and 1 because it's 3 to the 0, 3 to the 1, 3 to the 2nd, and 3 to the 3rd.
Good job, guys.
Okay, is 0003 allowed in this system or not? Yeah, so the answer is no, because in the base 3 number system, the only digits you're allowed to use is 0, 1, and 2, because that already gives you 3 digits. So basically, if you have a 3 in that area, you would result in an overflow, and you're supposed to move that to the next place over.
Yeah. So in reality, if you wanted to write 3, how would you express the number 3 in base 3? Are you guys sure about that? Let's see, well, what would 1, 2 equal? 1, if a 1 goes here and a 2 goes here, that would give us, this would be 1 times 3 to the 1st power. And over here, we would have a 2, right? So you would then add 2 plus 3 to the 0 power. So basically, this is saying you have 2 3 to the 0s. So 1, 2 would actually be 5. So that's not right. But 1, 0, in this case, this is 1, 0 is saying you have 1, 3, and 0, 1. So this would just, the 1, 0 would be how you would express 3. So now you guys got it. Okay, so it looks like okay, so this was just like a brief explanation of ternary. So now right now we've been dealing with like basically number bases that are smaller than base 10. So like base 2, we did a little bit of base 3 just now. But there are, yes, it is hexadecimal. We can also have number bases that are greater than base 10, like base 16, which is what this is. So this is base 16, also known as hexadecimal. Some people just call it hex values because, yeah. So basically hexadecimal is, can be used like in expressing colors. So in like RGB, like red, green, and blue values in like computers. So the first in RGB values, like the first 2 digits over here, like the hashtag is like, ignore the hashtag. The hashtag is just a hashtag. But the first 2 digits indicate how much red is in it. The second 2 digits indicate how much green is in it. And the third 2 digits indicate how much blue is in it. So something you might find interesting about hexadecimal is that for like base 10, right, you have the digits 0 through 9, but in hexadecimal, how many digits do you need? like in base 16, how many digits will you need in order to make it work? Yeah, so this is the interesting thing. Remember that in a number base, the number of digits is like the same as the like name of the number base. So in base 10, you have 10 digits. You have in base 2, you have 2 digits, which means that in base 16, you will need 16 digits. But unfortunately, since humans have basically grown up in base 10, we don't have 16 digits. So for base 16, we need the digits 0 through 9 as well as 10 through 15, but we don't have anything to represent that. So instead, what we use we actually use letters from the alphabet. So we have 0 through 9, and then we have A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, and F equals 15. And that's why you're finding all these letters on this like hexadecimal thing. Like you see a white is F, 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 F. That's because each of those Fs like represents like a 15. So like this is like, yes, white is basically like 15, 15. So in other words, the maximum red, 15, 15, maximum green, 15, 15, maximum blue. And then silver is just gray, pretty much, just light gray. Yes. So that's why you see letters in other number systems like that are bigger than base 10, because we ran out of digits. So once again, to reiterate, so in representing colors, the first 2 digits represents how many red is in the color, how much red is in the color. The second 2 digits represents how much green is in the color. And so the third 2 digits represent how much blue is in the color. So that's why white it's like completely maxed out. It has 15, it has the biggest digit in every place, because remember, white is like all the colors mixed in, whereas like black has like 0 in all the digits, because black is like no color mixed in. Okay, so a closer look at RGB values. So I sort of already said part of this, but each of the 2 letters corresponds to one color. So, oh, that's blue. So these 2 would represent red. These 2 would represent green. And these 2 would represent blue. And this is not, just to clarify, hexadecimal is a base system, but like color codes are different. So this is not one number. Like this big thing here is not one number. That's actually 3 separate numbers. One part that represents red, one that represents green, and one that represents blue. It's just that for the sake of reading it, they just shove them all together so it looks like a 6-digit number, but in reality, it's 3 2-digit numbers. So just to get that out of the way. So when I say it's like 3 2-digit numbers, what I'm saying is that like this number here corresponds to 255 in decimal. Can the numbers go over 255? When we're representing like colors, the max is 255. But in like a normal base 16 system, like if you weren't representing colors, you were just representing arbitrary numbers, then you can go over like whatever number you want. It's just that in representing colors, 255 is the max. So taking a look at base 16, so once again, we have our place values. So in hexadecimal, we have the ones place, which is 16 to the 0 power, which is similar to our previous bases. And then we have the 16th place, which is 16 to the 1st power. The reason why they don't want to go over 255 is because of this. So like the reason why they
16 times, isn't like 16 times 16 256?
Yeah. So the reason why so the reason why they chose base 16 was because they wanted to keep these like numbers really compact. Like if you notice, like if they like wrote the colors in like binary or something, instead of just using 2 digits for each color, you'd end up having to use like 8 digits for each color. So that's why they chose base 16. And the reason why they don't want it to go over 255 is because 256 is 2 to the 8th power. And so 255 is the biggest number you can represent in binary with 8 digits. And so in computers, each of these digits is called a bit. And so in computers, that means if there are 8 bits in a byte, then each unit of information is called a byte. And that's why 255 is the max value, because 255 is the max value you can store in a byte. So it has to do with computers, in other words. So just as practice, let's say I wanted to make a certain color, right? And I know I want to have like, I want to make purple. Let's just say I want to make purple, right? And so I want to have the RGB values. Oh, this is green, but okay. RGB values are going to be 100, which means I'm going to have like some red, 0, which means I'm not going to have any green, and then 100 again. So I'm going to have a little bit of blue as well. So we want to convert this into hexadecimal code. So in order to do that, we just look at each of these parts separately. So let's just convert the red part to hexadecimal first. So this is 100 in base 10 right now. So we want to convert this to base 16. So we set up our place values. So we have 16 to the 0 and 16 to the first power. So now, instead of asking, now how many times does 16 go into 100? So since 16 is the largest value that will fit into 100, how many times does that go into 100? Yeah, 16 goes into 100 6 times with a remainder of 4. So how many times does 16 to the 0 go into 4? 4, yes. 1 goes into 4 times. So that means that the hexadecimal code for 100 is 60 or 64. And obviously 0 is just going to be 0. So the next 2 digits would be 0, 0. And then finally, the third 100 obviously is just 64 again. So the hexadecimal code for this RGB value would be 640064.
So approximately what color would that be? Like
purple
Okay.
of some sort. Because for this color, you have a little bit of red, no green, and a little bit of purple. So red is plus blue, or sorry, wait. Okay, a little bit of red, no green, and a little bit of blue. So red plus blue is purple. So, and I know it can be sometimes hard to visualize. So we have a little activity. So oh, okay. So, okay, this is a little color picker. It lets you see the like different values of the color that you're going to choose. So see here it shows the hexadecimal value. Here it shows the RGB value. And there's another thing called HSL, which is called hue, saturation, lightness. That's another color system. I personally find it a little confusing. So I like RGB and hex. So when would you use base 3 in real life? Okay, this is very random, but I learned recently that they tried to make like a base 3 computers because apparently like base 3 is like more efficient, supposedly. So that's interesting. And I know in coding, they have other base 3 purposes. So like there are like trees, like decision trees that use like base 3 or something like that. Okay, let's see what 100, 0, and oh. 8. Okay. Oh, turns out that 100,
Pink.
yeah,
It's pink.
it's actually really dark pink. So not it's close to purple. I like this color.
It still looks like purple.
Yeah, it's still purple.
It's like purple pink. It's purple
Yeah.
pink.
I actually like
I
this
mean-
color a lot.
You can't find any pink in that purple, so.
I mean, if I drag it over here, then it starts to look pink. But
Did you know if you stare at the sun for 30 seconds and then close your eyes, you see green?
yeah, that's because your skin is red, and your red eye sensors get tired, and so that means the green takes over a little bit. That's the unscientific explanation. Okay, I'll just give you guys a few minutes to mess around and see how like the different values change. Okay. So now we can do a couple of problems with hexadecimal problems. With hexadecimal, although actually, I think we might just go to the Kahoot now because we have just 20 minutes. Ruth, Angela, do you think we should go to the Kahoot?
Yeah, that's probably best.
Okay. We will go do the Kahoot now. Okay. Can you guys hear the sound? No, okay. Because I can't either. I think it's because my AirPods, it's like if Zoom has audio, nothing else can have audio for some reason. Like I can't like watch videos while Zoom is going on. I don't know, it's very weird. Is someone playing Snake?
Who's playing Snake game in college?
Okay, we're gonna get started now. So if you want to join, just join. Yeah, I think you can see the questions on the screen. Oh, good. You have enough time to do this, hopefully. Convert this number to base 10. Okay, looks like most people got that correct. So, okay. So okay, this numbering is a little weird. So this is this one, and this one. So, okay, 0, 1, 2, 3, 4, 5, 6. Okay, so this is actually 2 to the 6. So that'd be 64. And then this one's 6, 5, 4, 3. So this one over here would be 8. And this one over here would be 2. So 64 plus 8 plus 2 equals 74. So that would be the answer. Good job. Okay, looks like we have banana car in first place. I literally have no idea who that is. What is 144 written in binary? Holy cow, that's a lot of zeros.
Educated guesses.
I mean, you could probably get away with not actually doing the problem in this one. Potentially, let me see. Yeah, you might be able to get away not doing the problem fully.
28 and then 16.
Yeah, and then after that, you can just.
I'm going with I'm going with how Audrey and Christina and the other person won the last Kahoot. Just don't worry about time and actually try to solve the problem. Well, I'm on the podium.
Okay, so for this one, I guess you could like reason your way out. So obviously 128 would be the biggest one that would fit in it, in 144. And after that, 144 minus 128 is 16. So obviously the next one that fits in it would be 2 to the 4th power. So it would be red. Okay, now it looks like Brian is at the top. Okay, if you convert 62 to binary, what number of ones is used to write it out? We can keep track of Colin's score on snakes just by listening to him play. Okay. If you convert 62 to binary, what number of ones will be used to write it out? So for this one, I'm actually going to show you guys a little trick. So 64 in binary is like the only one in it would be 2 to the 6 and everything else would be 0. So 2 to 6, 2 to the 5th, 2 to the 4th, 2 to 3, 2 to 2. Wait, shoot. Okay. But then if you subtract 1, it becomes 1, 2, 3, 4, 5, 6. So this is 63. And then if you subtract 1 again, it becomes 1, 2, 3, 4, 5, and then a 0. So this would be 62 in binary. So that's a bit of a shortcut, so you don't have to convert it like from scratch, if you know what I mean. Okay, Audrey's in first place. True or false? 39 in base 10 equals 1, 0, 0, 1, 1, 1 in base 2.
What the heck?
Okay, so this 39 equals this number. So we can convert this number so that 1 plus 2 plus 4 plus, and then this would be 32. So that would be 32 plus 7, so that would be 39. So this is true. Okay, we may need to go a little bit faster. So, okay, another true or false. That number is greater than that number. There is a little bit of a shortcut for this one, so you don't need to like fully convert the numbers. Just think about what the place values mean. Okay, so this is false because now you don't, I wouldn't actually convert the numbers. What I would do is this.
Oh no, shoot.
I would look at the first digit and see if they're the same. If they're not the same, move to the second digit. Are they the same? Then move to the third digit. Are they the same? Yes, then move to the next digit. And the next digit is different. This digit is less than this digit because 0 is less than 1. And you can just stop right there because that tells you that the number is less than the other one. Just like, you know, in base 10, like it would be evil if the first number had more digits. Oh, you're right. Well, double check to make sure that the digit the numbers have the same number of digits first. Otherwise, it would, yeah. Okay, Audrey is still in first place.
I'm at 6 now.
True or false? Oh. Wait, what?
Is this possible?
No, I don't think so.
Tell us the answer.
Wait a second. I'm a little confused by this question. Okay.
Was there supposed to be like a picture?
Which one's larger?
Yeah.
I don't know.
Can you check
Okay.
the Kahoot and tell us the answer, please?
Yeah. Please.
Sure, except right now.
Hurry up, the people are that gonna get like 1,000 points.
Oh, it doesn't say. You know, I'm gonna skip it. Just choose something random.
Guys,
This
it's
is
true.
not very fair.
True. Pick choose, guys. Pick true, guys.
Oh my gosh.
No, it's true.
Only 2 people didn't get
Y'all,
it.
I told you it was true.
Yeah, because B is bigger than A in the hexadecimal system. So
Oh, oops. I thought those were variables. Okay, I completely forgot about that. Okay, I was thinking about when Ashani was talking about the problem where B and A are variables. I forgot they are digits. So in the hexadecimal system, if they are digits, yes, B is greater than A. So yes, because A is 10 and B is 11. So in that case, this will definitely be true all the time. Oh no. Okay, which of these binary numbers is odd? Okay, for this, I'll give a hint. You only need to check the last digit because remember, all the place values are always even except for the last digit. And the last digit is like 2 to the 0 power, right? That's 1. So you should probably be able to reason it out based on that. Okay, looks like looks like you guys did pretty good on this question. So yes, if the last digit is 1, the number is odd. If the last digit is 0, the number is even. Oops, did not mean to. Oh, Audrey is still in first place. Okay, convert these to decimal and find their sum. Actually, okay, we may need to skip a few questions soon because we are only on question 8. I can't skip this one because several people have already answered. So
I don't think their sum is there.
oh, it isn't. Okay, let me do it real quick.
No, I think it is.
Actually, maybe.
Yeah, it is.
Yeah, it's there.
To make it fair for the people who win the Kahoots, the top 3 for each class get the 5 points?
I feel like that would be more fair. I don't know if it shows me like everyone's rankings though, so it will depend on what I can see at the end.
No, I think it does. Like after the game.
Yeah, I think that's if I'm logged in. I don't know if I'm logged in or not. So
Oh no.
yeah, but I will see if I can. Hopefully I'll be able to look at it. Okay, we didn't do a whole lot of hex to RGB. I'm gonna skip this. Oh my gosh, that one person got it right.
Bro,
Okay, who chose that? Who chose
Bruh.
that?
What the
Who
heck?
chose
that's
that?
cheating.
Who chose that? Okay.
I know
Who-
it was someone in like one of the higher places because I was in 6th behind Jasani, and then now I'm 7th.
Oh, it might be shock. Okay, we're gonna keep that in mind when we move on. Just keep that, you know. Okay, what is this question? Which of these binary? Okay, you guys can do this question. I'm sure you can. If you are a little upset about Shlok accidentally getting it right, just don't worry about it because okay, you guys almost all of you guys got it right. Yep. If it ends in a 0, it's even.
I hope Schlock got it wrong. Let's go.
What does D represent in hexadecimal?
Uh,
Okay, yep, D represents the number digit 13. Okay, looks like there's a bit of a shift. Hexadecimal is in second.
Audrey is just going.
Okay, Tamara says that base 7 uses the digit 0 through 7. Is she correct or incorrect?
What does it mean by use the digits 0 through 7?
So this is saying like you can use like base 7 like uses like
Oh, I see. Okay.
yeah. I don't know who hexadecimal is. Okay.
Oh
Yeah.
my God.
It would not be correct because remember the
It's 0
base,
to 9.
yes, just like there's no digit 10 in base 10, like you actually write 1 0 to
I
represent
thought
10.
it meant it use multiples of 7.
Oh,
Oh my gosh.
yeah, it would be 0 through 6. So
I'm in 10th now.
okay, I'm gonna skip this question. Oh, well, okay, never mind. I'm not gonna skip it because some of you guys guessed. Don't guess if I'm going to skip a question. Actually, I'm not gonna announce it from now on. Okay, this is okay. Okay. Oh my goodness. Okay. We are speeding to this, guys, because it's 11:29. We didn't teach you guys how to subtract. Okay. Okay. Why does the ones place exist in every base? Oh no.
The answers aren't explained very well. I guess they're not presented very well. Not 100% what the answers mean.
Yeah, some of them are purposely vague. Don't choose one that's vague. If it sounds like it might be correct, it probably isn't correct. There is one that is concrete though.
I chose a very vague one.
Oh. Okay,
Yeah,
so it is yellow because if you think about it, the problem with all the other answers is that like they are vague. You don't know what it means when like a number system is built around one or like it's necessary. Like
or what
because,
the identity number is.
Yeah, notice that like no matter what, since the exponents are always going to raise something to a 0 power, that's why there's always a ones place because that place is always going to be 1 because anything raised to 0 power is always 1. Okay. Oh gosh. Okay. Okay, we can do this one. Okay, I know it is 11:31, so if you guys have to go, then you can. Oh no.
Oh.
Oh, looks like it's blue. Okay, last question. Which one of these hexadecimal numbers is odd? there is like a shortcut for this one as well. Okay, if you haven't already answered, you may want to answer soon.
It's gotta be blue. Purple.
I mean, yellow is odd. But like, I'm not sure about hexadecimal stuff.
Yeah, we went over hexadecimal very briefly.
Y'all choose purple.
Okay, so the answer is yellow because this is the only, if the last digit is odd, then the number is odd. If the last digit is even, then the number is even. So this is the only one with an odd last digit. Okay, in third place, we have Advika. In second place, we have hexadecimal. Hexadecimal, you need to review your identity. And in first place, we have Audrey. And we have James and Shlok as runners up. Okay, who is hexadecimal? Because I can't give you points if I don't know who you are. Shriram, okay. Okay, I think I will be able to see the ranking, hopefully. So I will split the points up by class if I can. So
I don't think Schlock deserves to be there, because
I can like, I'm probably, I mean, I'll take a look at it.